Okay, there's one more file loading, but we can go ahead and get started. So I'm looking at the exam 2 study guide, and the first learning objective on there is to differentiate between motivation and emotion, or distinguish between emotion and motivation. So do you have any questions about that, or what I'm going to do is show you, hold on a second. Okay. Okay, so this slide is kind of cool because it shows you that motivation and emotion are not the same thing. And so they kind of work in a circular fashion with each other. So motivation is the whatever motivates you. It determines what kinds of things you pay attention to, and then once you've achieved whatever it is you're motivated to do, then your emotion kicks in. Excuse me. So whatever makes you feel good, or whatever you want to get away from, is sort of what motivates you to, excuse me, to take action. And then once you, when you have that feeling, it increases the importance of whatever had motivated you. And then, of course, it just continues on in a circular fashion. So does that make sense, Natalie? Do you have any questions about that?
Yes, that makes sense. I don't have any questions so far.
Okay, all right. And I'm just going to run through the different objectives and see if you have any questions. So let's see. The second one on there is to explain the biological, social, and cognitive correlates of emotional expression and assessment. So that involves quite a few things. So when you're trying to define what an emotion is, you have to look at all those components that actually were mentioned in that question. So your cognitive component, that's whatever you interpret a stimulus to mean for you, and it's real similar to in the sensation and perception chapter, where the perception is what you actually interpret a signal or a stimulus is. And then your feeling is what you label something as. And then the physiological response, of course, has to do with how your body responds to things. And then the behavioral, a lot of the research that's been done on emotional expression has been done looking at people's specific facial expressions and their facial muscles that are involved. So, those are the different areas of or components that make up emotions. And of course, there are a lot of different parts physiologically that make up your emotional expression. For example, the amygdala, which is the emotional detector and memorizer in your brain, that's really important because it helps us memorize, especially emotional events in our lives. And it also helps us, it just sort of goes into high gear when there's something emotional going on. And then if you look at the research that's been done on emotional expression, these are the 7 universal emotions that have been identified by a psychologist named Paul Ekman. And people around the world pretty much universally express their emotions facially in the same way. So this one, for example, is for happiness, and this one is for surprise, and this one's for contempt, this one's for sadness, this one's for fear, and this one's for disgust, and then this one is for anger. And if you look at I don't know if you've seen the movie Inside Out, but those producers actually got neuroscientists to weigh in on this movie, so that the expressions that you see from the different characters, anger, disgust, joy or happiness, fear, and sadness, I mean, they're expressed very well in that movie Inside Out. So if you've not seen that, I recommend it. Have you seen that, Natalie?
I have.
Yeah, it's pretty cool. So, and then this is an example right here of the universal expression of emotion. So these are obviously 4 people from 4 different cultures, and they all express their motivations with a smile. What's different in their smile is that in some cultures, it's not appropriate to be very expressive in how you display your emotions. So, for example, this lady right here, this person right here, she's not expressing her smile as largely as, for example, this person. So, in the textbook, there's a really nice bar chart that shows you that various cultures around the world, they express emotions much more demonstrably than do others. So, for example, this bar right here, it shows you that in Hong Kong, it's not emotional suppression is very large, and so it's not real appropriate within their culture for people to display their emotions in a really large way. So they have they are least likely to show their emotions in a real strong way. Whereas the opposite of that is Switzerland, and in Switzerland, they very much will display their emotions and let you know how they feel. So those are they just have different rules about what is appropriate to express emotions or not. So, oh, and one slide I forgot to show you about emotions is usually the way it works with emotions is there will be a particular stimulus. For example, here, this is probably a scary one. And so whatever part of the brain is responsible for helping us interpret what that stimulus is the one that will generally be activated. So for this example, it's the occipital lobe in the back of the brain. But of course, if you remember back from the neuroscience chapter, the thalamus, which is the relay station in the brain, the retina will send a signal to the thalamus, and then the thalamus sends a signal to the occipital lobe, then to the amygdala, and then to the prefrontal cortex, and that's what tells us, lets us know how we're supposed to respond in a situation. So since this is a scary symbol, usually our fight or flight response will kick in. So if it's a scary or if it's a situation where we need to survive, the brain will actually skip the brain area of the part of the cerebral cortex that is responsible in the interpretation, and so what would happen is the retina would send the signal to the thalamus, and instead of the brain going to the occipital lobe, the thalamus would directly symbol the amygdala, because the amygdala needs to hurry up and let us know this is dangerous. So we either need to run or we need to prepare to fight. So it's really amazing how our brain and our body helps us respond. And excuse me, of course, the autonomic nervous system would kick in in a situation like this, and we might start sweating. We might start shaking. Our heart would beat faster, and so on. So our bodily response, and remember the components of emotion right here, the physiological response, that's really an important part of our defining and understanding how emotions work. So, all right, so let me look at that study guide again and see. Motivations of affiliation and achievement in light of systems. Describe the motivations of affiliation and achievement in light of systems explaining the prioritization of motives. So in that one, oops, here. Primarily on that one, I was looking at first looking at thinking about Maslow's hierarchy of needs, and how he stated, he was a humanistic psychologist, and he stated that we have these different levels of need, of emotional needs, or needs that we need to at least fulfill our highest potential as human beings. And so we start at the very bottom and we move all the way up. And so it's a good framework or structure for helping us understand what it means to be a fully functioning human being. So we have to get our lower level needs met before we can meet our higher level needs. And of course, people have criticized this because, of course, there are people who forego their lower level needs in order to meet their higher needs, which are their needs for achievement and competency and so on. Because some people will stay up all night studying for a test because they want to do well on it, which is an achievement need. And then they may skip sleep, which is a physiological need. So, or they may skip food and water. So it doesn't always work that way, but typically in order for people to survive and reach their full potential, then they need to have their lower needs met first before they move to the higher ones. And then the other piece of that that I wanted you all to take a look at, well, let me just do Maslow's self-actualization, which is when you reach your highest level or you meet your full potential. These are his characteristics of self-actualized people, which are these are people who they feel like that they have a mission in life and that they have attained their mission. And then they're very spiritual because they have these mystical and peak experiences. So he named quite a few historical figures such as Gandhi and Eleanor Roosevelt as people who were self-actualized. He also named Abraham Lincoln. And if I were making this list, I would put Jesus on here. I'd put Martin Luther King Jr. I would put people like that. So, that's Maslow's. It's one of the most famous theories of motivation, and it's got that level of the achievement need in there. And then that even though that objective doesn't state it, I wanted to make sure you knew the physical part of motivation, which is your hypothalamus is the particular area in the brain pertaining to meeting your biological needs, because it's the area of the brain that triggers your need for food, water, sex, sleep, and so on. So it's really important. And then the other piece related to achievement and so on is we have what's called intrinsic versus extrinsic motivators. So extrinsic motivators are things that are externally, and so somebody may sell cars so that they can get that commission from selling the car. So they're looking for rewards, and it's in the next chapter where we're looking at excuse me, where we're looking at different when we're looking at that theory of operant conditioning, where you do things that you'll get rewarded for. That's extrinsic motivation. And then intrinsic motivation is where you're motivated because you want to do something that's meaningful for you. So I think this next slide explains it a little bit more. So excuse me, when you're motivated intrinsically, it's from within, and things are a labor of love for you. When you're, and so an example is you're learning for learning's sake, and you're reading a nonfiction book on a topic because you're curious about it. Extrinsic, again, it's motivated from without, and that kind of motivation is sometimes seen as a chore. So basically, making an A. If a parent rewards a child for making an A by giving them money, that's an extrinsic motivator. It's not really a good practice to follow, because then the student's own curiosity for learning will sort of be tamped down. And then also, if you pick a college major based on how much money or how prestigious it is, then you're motivated extrinsically. And of course, extrinsic motivation is what you want to shoot for, because those are the things that'll really make your life fulfilling for you. However, extrinsic motivators are they're important too, because they can work for things like if you want to lose weight, and you get immediate rewards, like if you wear one of those Fitbits, those are extrinsic motivators for you, because you want to get all your steps in. So both can be used. It's just that if you look more towards things that are fulfilling, typically it'll make your life more meaningful. So I think that's everything on that chapter 7. Were there other questions you had about it, Natalie?
Did not know. Thank you.
Okay, I'm sorry you're the only one on here.
Okay.
Okay, all right. So I want to try to make sure that I get to all the things on the next 3 chapters. So I think what I'm going to do is I'm just going to look at the objectives, and you tell me if there's a specific question you have on any of the objectives. And if I think I need to throw up a slide, I'll do that too. So on chapter 8, let's see here. Let me get to that. Chapter 8. Okay, so chapter 8 is wanting to make sure you know the difference between reflexes, instincts and learned behaviors. So were those clear to you when that was explained? I do have what? Go ahead. I'm sorry.
I would say they were pretty clear. The instincts and reflexes were a little blurry, though.
Okay, let me. Yeah, because I mean, with learned behaviors, there has to be a cognitive learning process, and it's a change in behavior from your experience. But with the reflexes and instincts, it is a little bit confusing. So let me get back here. Okay. Okay, so with reflexes and instincts and learning, there are all ways in which we humans and animals respond and adapt to our environment. But the way that they differ is how complex they are and how flexible they are, and so and the role of experience. So with reflexes and instincts. They are not really they're not anything that's learned, and they're not flexible because they follow the same pattern for a species, and you don't need any experience for a reflex or an instinct to occur. So let me show you a couple of examples. Okay, so a reflex is something that comes from the lower part of the brain. For example, if you're having a neurological evaluation and the doctor taps your knee with one of those little hammers, then what happens is there are signals sent to the brain, and your thigh muscle stretches out, and so your foot kicks, and that's not anything you have any control over because it's a reflex. It just happens. Another example of a reflex is if an object comes towards your eyes, what do? You blink, and you don't really have any control over that. It just happens. And instincts. Those are things that a species does, again, without any kind of learning, but it's a little bit more complex than reflexes are. So an example of an instinct is a baby kangaroo. It'll climb into its mother's pouch immediately after it's born, and it doesn't get any instruction or coaxing from the mother. It just does that. Another example is salmon. They swim upstream at the same time every year to spawn so that their species can survive. And nobody tells them to do that. It's just an instinctual behavior. And then when you think about birds, they fly north and south, and it's an instinctual behavior. It's a way for their species to survive. Bears hibernating in the winter. I wish I could hibernate this winter. Those are instinctual behaviors, and again, the species doesn't have any control over it. We can name human reflexes, but human instincts are a little bit harder to come up with examples for. It's real easy with animals, but it's a lot harder for humans. Maybe for humans, our biggest instinct is that we fight against a death, and we have an instinct towards survival. But to come up with specific examples, it's much harder. Okay, so does that make it more clear?
Yes, ma'am.
Oh, good. Okay. So let's see. Let me look at the next one. So, okay, so knowing the different elements, classical conditioning, and what's the difference between an unconditioned stimulus, a conditioned stimulus, conditioned response, and a conditioned stimulus. So I'll just show you a real quick slide that helps you figure that out. Pavlov, of course, is the one who came up with that. Okay, so this triangle really helps me. Excuse me. An unconditioned stimulus is one where there's no conditioning required to get an unconditioned response because it is a reflexive response. But then when you pair an unconditioned stimulus with, at first it's a neutral stimulus, but it becomes a conditioned stimulus, and that's the conditioning. You have to have conditioning to get the conditioned response. So with Pavlov's dogs, the unconditioned stimulus, excuse me, was the meat, and how they, or the food, and they responded with the salivation, which is it's a natural reflexive response. But after the pairing of several different sounds, Pavlov was able to get the dogs to actually salivate to the sounds. And of course, the conditioned response, it's not a natural response because it's not natural for a dog to salivate at the sound of a bell just by itself. So that's how this triangle helps me remember it. And I was going to let me go back up to Watson, who was excuse me, he took Pavlov's research and he applied it to children, and he conditioned them to be afraid of a white rat. So, and how he did that was he paired a loud gong with the rat, and so then the children became fearful of the white rat. So a loud gong is something that, yes, the little children would be naturally fearful of. And the rat, initially, a little baby, young child would be just curious about them and wouldn't have a fear response. But after that pairing, just the rat itself causes in this case, it was little Albert, to be afraid of the rat. And he also did what was called stimulus generalization, where he was afraid of also other furry things. So, so that we wouldn't let Watson do that today because using children in this way would be considered very it would be considered unethical. So Watson took his classical conditioning, what he knew about it, out into the advertising world, and even today, advertisers use classical conditioning to try to get you to buy their products. Here's an example. I pulled this ad for beer off of the internet. And so these people at a party are having, they've taken the goldfish out of their aquarium and put them in a bag of water, and they've used the aquarium to ice down their beer. So the unconditioned stimulus there, of course, is the goldfish outside the aquarium, and the people are having fun. So that would naturally produce this feeling of humor and a pleasant emotional response in you. And so they're pairing that situation with their product. And so what they're hoping is that when you're at the store and you happen to see that product, in this example, it's beer, that your conditioned response will kick in and you'll buy that product. And that's what advertisers do to us. So that's classical conditioning. And then I believe the next next one is for operant conditioning. And let me just quickly show you a slide that helps me figure out operant conditioning. So with when you're trying to figure out whether something is a positive reinforcement, a negative reinforcement, or punisher, or a consequence, what you have to do is look at when the consequence or the stimulus is introduced and what its purpose is, and then I've got some examples on there. So if it's a positive reinforcer, it's pleasant, it's after the behavior, and what you're trying to do is get those behaviors to continue. So, you know, when you put gold stars on children's homework, well, that hopefully will get them to do their homework in the future. Now, negative reinforcer is something that's unpleasant, and it occurs, though, before the behavior, and then it's removed after the behavior. And because it's a reinforcer, you're trying to increase the likelihood of that behavior in the future also. So with Skinner, he had those Skinner boxes. I'll go back. I'll show you that in just a second. So he would have a shock on the kids in the Skinner box, and when the rat would press the lever, the shock would stop. And so that's a negative reinforcer. And then if you have a headache, that's a negative reinforcer. If you take an aspirin and your headache goes away, what happens? It increases the likelihood that you're going to take an aspirin in the future to make your headache go away. And then a punishment, of course, is after the behavior, and it decreases the likelihood of the behavior occurring in the future. And examples of that are spanking and time out. So let me show you that the rat right here. Okay, so oops. Okay, so this is an illustration of a Skinner box. So he would have the shock go on these grids right here, and the rat would press the lever, and it would make the shock go away. So then the rat would that pressing the lever behavior would continue, because the rat learned that if it did that, it could stop the shock. It would do loud tones too, and if the rat pressed the lever, the loud tone would go away. And so the rat learned that if I press the lever, then the loud tone will go away. Let me give you some other examples of positive reinforcement, negative reinforcement, and punishment. So here, of course, treats are a good thing to teach animals tricks. So you can teach a dog to beg if you give it a treat after begging, and so it'll learn that if it begs, it treats. Here's an example of a negative reinforcer. A woman it hits her snooze button. The snooze button, which is the annoying noise, will go away, and that means that she'll continue to hit the snooze button in the future, and that's the behavior, hitting that snooze button to make the a noise go away. Here's an example of a punisher. If you scold a kitten for scratching on the furniture, hopefully that's going to make the kitten stop scratching the furniture, hopefully. One of the issues that Skinner had with punishment, he really thought that you shouldn't do that. He thought that you should use negative reinforcement, positive reinforcement, because if you punish to try to get behavior to occur, or actually, excuse me, to stop behavior, then basically you're making the animal or the human fearful of you, or you could make the animal or the human aggressive. So if there are other ways to do it, let's don't do punishers. So Skinner was not really a fan of that. So another thing related to Skinner's theory is what he called shaping. And shaping is when you don't reward the exact behavior you're trying to get, because if you wait until you get the exact behavior, you won't ever get the behavior. For example, when we potty train children, we don't wait until they actually use the potty to reward them. We have to actually start by encouraging them just to sit on the potty and reward. So that's rewarding them. So this is when he shaped a dog named Agnes to come in the room and jump at these horizontal bars that he had painted or taped on the wall. And so it took him about 20 minutes, but what he had to do was he had to reinforce her for doing behaviors that looked like what he was trying to get. So, okay, so that's operant conditioning. Any questions? I know I went through it kind of fast.
No questions so far.
So none so far. Is this helping
Yes, ma'am.
all? Okay. All right. So I think the next one has to do with observation learning, and so cognitive learning, or one type of cognitive learning is observational learning. Classical and operant conditioning, they are both what's called pure behaviorism, and they don't really take into account the thinking processes of animals or humans. Those theories believe that we're just responders to our environment. But with the cognitive theorists, they think that we have a choice. And Albert Bandura was one of the cognitive learning theorists, and his theory is observational learning, which is when we mimic the behaviors of other people. Not just humans do this, but animals do it too. And we have a choice as to whether or not we're going to do that imitation, and we don't necessarily have to have any kind of a reward for doing the behavior. We just learn and observe. So Albert Bandura was he was very much had some very some research that was really well received, and it was very well done, where he had children watch a televised or a filmed picture of a woman beating up one of those Bobo doll things that, if you punch it, it comes back up again. And she said things like "pow" right in the nose and "suckaroo, stay down." And so his experimental group, children who watched the televised the film clip, and then he let them go into a room, and they and there were other toys in there, but the ones who had watched the woman, the model, they went immediately to Bobo and started doing what she was doing, even used the words that she used to beat up Bobo. And this next slide shows you the little boy and the little girl, or two of his experimental group children. They were preschoolers, and they whacked up on Bobo. And the majority of the children in the experimental group who saw this, they actually imitated this aggressive behavior. So it's kind of scary when you think about it. And then there are other examples of observational cognitive learning. I mean, medical students observe real surgeries before they are actually given a knife to cut on patients, and coaches do it. And if you watch Dancing with the Stars, you could probably learn and imitate some dance moves yourself. So that's all for chapter 8, unless you have any questions.
I'm good so far. Thank you for doing this.
Oh, you're quite welcome. I wish more students had come, but maybe the ones who couldn't come will watch the video, and that'll be helpful for them. So now we're going into chapter 9. Okay, the first one is about encoding, storage, and retrieval of memories. And then sensory short-term and long-term memory is number 2. And then organization of long-term memory, retrieval, why we forget, and the biology of memory. So let's see here. Okay, so we have, there are 3 processes in human memory. There's encoding, which is getting the memories in there, and there's storage, and then there's retrieval. And for the storage process, we have memories based on all of our senses. So we have visual memory, we have acoustic memory, and we have haptic memory, which is touch memory. And then we also have short-term, and sometimes it's called working memory. And then we have long-term memory. So there's episodic, semantic, and procedural. And then we have to move information from sensory memory to short-term memory to long-term memory. And once we get information into long-term memory, so we go encoding, storage, and then we retrieve it out to use it again. And that's when the short-term memory is the working memory, because we're retrieving it out of long-term into the working memory to use it in real time. So let's see. Let me see what. Okay, so I'm going to assume we've encoded the memory from sensory to short-term. And short-term memory is limited in duration of about only 20 to 30 seconds unless we rehearse it. And that's when we repeat it over to ourselves, or we verbalize, or we think about the information. And then it's moved into long-term. But it's limited in capacity, how much information you can store in there at any given time, 7 plus or minus 2. I think that is a question on your quiz questions for Chapter 9. Unless you chunk the information and put it into to a meaningful format. So let me see if I can. See if I can do this. See if I can give an example. Okay, it's not very good drawing because I'm not very adept at this, but I just want to show you this as an example for chunking. So say these are 12 letters, and if I ask you to try to memorize those, it would be really hard for you to do because it's beyond the capacity of short-term memories, because 7 plus or minus 2, 9 would be like most people's max. But if I take it and chunk it and put it like this, so now I've got the FBI, the CIA, and ICE, and DEA. And because I've put it in meaningful chunks, you would be able to just jot down all those letters for me, because those are acronyms for law enforcement agencies. Does that make sense, Natalie? So that's how you have to check information, like with phone numbers and different things like that.
Yes, ma'am, that makes sense.
It makes sense? Okay. All right, so let's see now. So as far as we know, our long-term memories are unlimited in capacity and the amount of information that can be stored in there. And the reason we think that is because of flash bulb memories. We especially important events that happen in our lives, we have really good recall for those, although our memory is not like a tape recording or a video recording. When we pull it out and use it, it doesn't go back in the same way. And so we have to be careful about that, assuming that our memories are the same. Because when we bring them out and we talk with other people about them, when they're restored, they're in a different format. So our memories are changed as we use them, but we still do have really good recall. And I mean, our human memory is just it's phenomenal as to its capacity and its storage. So this is an example of a flashbulb memory. They're long-term memories that are emotional, and the amygdala is really involved in, as I said in the other chapter, in storage of long-term memories. So we have declarative memory, which is explicit, and that's semantic and episodic. So semantic memories are things that your general knowledge, things that you learn in school, like these are breakfast foods. Episodic memories are memories in your life. Now, procedural memories, on the other hand, those are long-term memories that are for how do you go about doing something. So now we've got information encoded, stored, and now we want to retrieve it. And so why do we have issues sometimes with getting information out of long-term memory? So first of all, we need to have cues to help us remember. And so that's why people, in their passwords, they usually try to use common things to help them remember their passwords, because those are cues. Let's see, what else do I want to make sure I remember? Okay, so we have, there's something called a serial position effect that's involved in our forgetting. So if we're trying to memorize something like a list of words, our recall will typically be where we'll remember the things at the beginning of the list and the end of the list. So the beginning of the list is the primacy, and the end of the list is the recency, and the words that we'll forget are the ones in the middle. And so we tend to forget the middle information and remember the beginning and the end, and that's called the serial position effect. And something else that's related to forgetting is massed versus distributed practice. That mastery training, that if you've taken advantage of that is using this principle where if you learn things in small bits of time that are distributed, you are more likely to have recall than if you wait until the last minute to study, and that's called mass practice. And the psychology research shows us that we're more likely to forget if we do the mass practice versus the distributed practice. So let's see if there's anything else on forgetting. So the biology of memory is that acetylcholine is a neurotransmitter involved in memory. Also, there are brain structures involved, particularly the hippocampus. It helps us in long-term memories. For semantic memory, what's interesting is that whatever lobe of the cerebral cortex is involved in the sensory part of that memory is where we'll store it. So the occipital lobe is where we'll tend to store visual objects. The motor cortex is where we'll store information about how to use different things. So that's really kind of cool. let's see. I think that's pretty much it for the that chapter. And then the last one is on. Are you needing to get off? Because I know I said 1 to 2. Natalie, how are you doing?
I'm good. I don't have anything else to do today.
Okay, all right. Well then, okay. Well, that's chapter 9. Now let me see what I can get through for chapter 10. Um, let's see, just to. All right. 10. Okay, so the objectives there are asking about general intelligence and then multiple intelligence, and then also talking about nature and nurture and explaining individual differences in intelligence. So, if if you ask 10 different psychologists their definition of intelligence, you'll get 10 different definitions because they don't really necessarily agree. And there are all these different kinds of uh, debates about whether intelligence is more nature or if it's more nurture. And so that um, and it's kind of like all the other things we've studied in the class where it's not either or, it's both and. So even with intelligence, it's nature and nurture. So, um, so G is general intelligence, and that's typically what would be measured on an IQ test, which is where they set uh, the scores in what's called a normal distribution. So this is an example of a normal distribution where from 85 to 115 is considered average. That's where most people would fall, and only a few people would fall over here, which is in the intellectually, well, it'd be lower than 70, in the intellectually disabled category, and then only a few would be considered in the gifted range. People can't be labeled intellectually uh, with an intellectual disability unless they have some issues with their everyday functioning. For example, if they have trouble with their social skills, or if they have trouble with their schooling, or if they have trouble with keeping up with their money, things like that. You don't just label somebody as having an intellectual disability just because they test on the lower end of an IQ test. And then, so let's see. Let me see. So some of the things about group differences in IQ scores. Um, so every generation in the 20th century, each generation scored higher on IQ scores, and this is called the Flynn effect, which is an argument for the nurture side of IQ scores, because as people's lives got better, then and they were able to have more education, and there were less infectious diseases and all kinds of things like that going on in the environment. People's scores got better. And we certainly wouldn't say that we're smarter than our grandparents or our great grandparents or even our parents. Um, there's something in the environment going on that's boosting up those scores. It has to be education. It has to be better nutrition. It has to be better uh, control of infectious diseases. Although, of course, I know now there's one upon us that we've got to get control of the COVID. Of course, researchers use twin studies when they're studying nature nurture, because twins typically will have very similar IQs, identical twins especially. But in our textbook says that about 75% of our IQ is related to inheritance, and that's the heritability rate. But there are other sources that say that it's lower. Here's one that says that it's 50-50. If you remember the heritability things that we studied back in chapter 3. So the psychometric psychologists, they want to quantify an amount of general intelligence that's similar across all cultures, but we know that there is cultural bias in these tests, and so there are other researchers who believe in intelligence being more than one thing. And one of those people is Robert Sternberg, and he has a theory of intelligence that has 3 parts to it. So there's analytical intelligence, and that's what's measured on an IQ test. Those are things where we learn, intelligence, we solve problems, and we learn how to think critically and so on. A lot of the things that we learn in school, actually. But he also says that there's creative intelligence and there's practical intelligence. Creative intelligence is coming up with new and novel ideas, and that's not measured on an intelligence test. Neither is your practical intelligence, which is your street smarts or your common sense, and that's being able to navigate in your own environment. And so IQ tests don't tap into those kinds of things, which are really, really important. And then Howard Gardner, he says that yes, there are certain parts of your intelligence that's measured on an intelligence test, but and those are your linguistic intelligence and your logical mathematical intelligence. He says you also have all these other intelligences that are not measured on an IQ test. There's spatial intelligence. There is one subtest on an IQ test that will tap into your spatial intelligence, but for the most part, it's not looked at. And then your spatial intelligence is your ability to see in three dimensions, and to your own internal GPS. Kinesthetic is bodily intelligence. Musical, of course, is understanding tempo and all those kinds of things. Intrapersonal intelligence is your ability to understand your own emotions and use them wisely. And interpersonal is social skills. And then naturalistic would people going in to become biologists or farmers or so on. None of these are measured on an intelligence test. So Howard Gardner is a professor at Harvard University, and he says that intelligence is more than one thing. And Gardner says that, and so does Sternberg. It's more than one thing, and that there are cultural differences because when you think about practical intelligence, what is practical for here in Bowling Green, Kentucky, is different from what you would need to survive in the Amazon. And you can't say, indigenous tribes in the Amazon are less intelligent than you are just because they've had different educations than you have had. I hope that makes sense, Natalie. I think that's a good that's a good like really fast review of all those chapters. Do you have any other questions related to those chapters?
I do not.
You don't? Okay. Well, I thank you for coming. I really appreciate it. If you got any other questions, I know I extended it so you all don't have to have the exam done until tomorrow night. So if you've got questions between now and then, please send me an email.
All right, I will.
Okay. All right. You have a good rest of your afternoon, and thank you for coming.
Thank you.
Okay. Bye-bye.
Bye.